All right, let's just get rolling here. Welcome to first afternoon sessions here on the first day of 3D Experience World. First timers? Anybody else first timers? First timers. I didn't see badges on everybody. You're supposed to get. Oh, there you go. Most everybody got a big.
We were driving in yesterday, so we like went to our hotel around 8.
Gotcha. Well,
It's a little late.
keep an eye out. Somebody might have some of those tags somewhere. Wonderful, wonderful. Okay, well. I am predominantly a SolidWorks guy, but I've been working a little bit with robot programmers, so that's why I wanted to do a presentation on that. So you're going to hear this from a perspective of a non-robot expert, but that's actually the beauty of it, because you don't have to be a robot expert for this kind of stuff. Now, cursory knowledge, that's where you've got the advantage, but we're going to go through quite a bit here and show and tell, and I'm really just going to do an information dump and show you as many things as I can in a short amount of time, all right? Very good. So my name is Darren. I'm with Go Engineer. I've actually been doing this 3D Experience World, SolidWorks World thing since 1997. So I have not missed one of these conferences yet. So the first timers here, there's a never miss on my badge there. So 28 years in a row on this one. And I've kind of grown up from 3,000 users of SolidWorks worldwide to what we have now, which they said was 8 million. And then add the platform on top of that. So that gets us a whole host of other applications and things. But I grew up in Michigan my whole life, went to Western Michigan University, got an engineering degree there, and with an engineering degree, you can pretty much do anything you choose, especially when you know a CAD system. So today we are not talking about CAD, but obviously these are the peripheral tools that leverage the stuff that we design. And obviously for manufacturing, people who don't live in a vacuum like I do, you actually have to cut chips and get parts out the back door and other things. So that's why we want to talk about this. So I want to break this down into 4 pretty much just topics. This will be sort of death by PowerPoint, but I have a lot of video built into this since we don't do live demo in these situations. But I'm going to give you probably something you've heard from other people, but it can't be heard enough times to understand it, is what is 3D Experience? Because really for everybody, it's a different thing. Everybody's needs and perspectives and information coming in. How you doing, Todd? Didn't expect to see a celebrity in here, but very good. So I'm going to describe that to you a little bit, and then we'll get into the robot programming in the cloud. I want to talk about what it is, just to demystify even the capabilities, because when we're talking about the platform, even when you think you know something, you probably only know a bit of it, and there's a lot of places you can go with it. Licensing, especially on platform tools, is very, very compartmentalized. So you buy only exactly what you need. It's not like SolidWorks where you buy SolidWorks Professional and you get a whole bunch of stuff. You just buy piecemeal. And it really does allow you to be more effective and more strategic with your dollars and get the things that you want. So we'll talk a little bit about that. And then I'll throw some sort of live demo stuff. Like I said, we pre-record videos here just for the sake of continuity and time. And I just want to show you some of the functionality so you can visually watch it. And I'm a visual guy, so just seeing things, you pick up functionality and really knowledge on how to. And then kind of where you can go from there. So first, what is 3D Experience? Again, everybody's got a different definition of this, but it has really proven to be kind of an open-ended, scalable development platform. What you know is what you know, but where you can go is almost infinite. And I don't say infinite and always often, but I have not gotten anywhere near close to understanding the vastness of the platform and what's capable. And every time I talk to somebody new, I learn something new about it. So really, even this line here, the 3D Experience is available as both a hybrid and a cloud hybrid. But it's also available on-prem if you have enough money, which means basically your own locally loaded version of 3D Experience platform, which places like Boeing and places like that do that. But as far as all we're concerned here, we're talking about applications that either are 100% accessible through a browser. That's going to be really how your licensing is with the platform. And I'm using 3D Experience SolidWorks, which my SolidWorks licensing is on the cloud, as opposed to a local network license or a local machine activated license. So, anywhere you have web access, you have access to your licensing and your data. Now, some things are cloud only. There are tools like, Project Release Engineer. You can only use that inside of a browser. Xshape, Xdesign, the cloud apps only work within a browser. But then you get these things that we call hybrids, and that's really where SolidWorks actually comes in. SolidWorks will live on your desktop. I can't say it because I'm not the developers, but I see no change in the way it installs, and our user base is huge, so don't mess with a good thing. But SolidWorks is always going to be locally installed. Even my 3D Experience SolidWorks is locally installed, though it is licensed from the cloud. I just get updates from the cloud, and everything is more seamless. But that's also where Robot Programmer comes in. There is a host of things that have to be installed locally, and performance is subject to a computer that's got those types of things. But really, it's more C++, redistributables and other things for the VB that's necessary for creating these tool trajectories and things. However, again, mostly loaded locally. You start it up from the platform, and then you're good to go offline for the most part. Now, this is the bubble I typically live in, so I'm getting outside my comfort zone a little bit here, so be kind if you have questions. If I don't know, there are several people above me that are my phone of friends, so I've always got backup, so I can go to them. But from a brand standpoint, we're all pretty familiar with these. I think you see this ad nauseum from the Dassault leadership on different slides and graphics over the years. Now, when we're talking about this and some of the things you don't see, like 3D Via and those other brands, the 3D Experience platform lives in the middle of this. And even after using this, I've been on platform applications since 2008. I heard somebody else, Mike Buckley from the Delmia group, really explain it in a way that finally hit me. And that is really, the platform is kind of the black box. It really is the center of everything. And when we talk about that, stuff from SolidWorks and CATIA goes into that black box, and then it gets used out in Simulia and Innovia, which is the data management stuff, and of course Delmia and any of the machining applications. But it literally is the closest thing that I have found to data coming in from any source being used in any other receiving source. So as complex as it might seem and unwieldy in some cases, I think the vastness is the unwieldiness, not that it's a bad thing. That's really a fantastic thing when you think about it. Here, we talk a lot about just what we know, which CATIA and SolidWorks are the primary modeling applications that we're dealing with in this particular community. And those put data into the platform one way or another, simple save as. And then from there, the data can disseminate it out into tools like Delmia. For today's sake, we're really just kind of dipping our toe in the water at the beginning of Delmia because, again, it goes so much further based on what you need. So the low-hanging fruit takes care of a lot of people, and I hope that gets you at least a little visibility on what it can do. If you need that next step up, I'm gonna talk to you about really where those levels come in, and if you need more, there's always more, is really kind of what it seems to be. The CAD that we do is on top of the CAD that the platform actually does support. So when you think about it, anybody that's had 3D Experience Platform administrative access, the platform management tools, you can go into the CAD connectors and you basically see this entire list. This is how we set it up to make attributes and properties and variables and things come in directly from the CAD files that are all variable, and then go ahead and get put into things like the title and the description information on the platform. Now, of course, SolidWorks and CATIA, those are the ones that we're more familiar with here, but again, it's a black box. We add in the sidebar on the right-hand side, that little tab, the compass, and the compass effectively connects whatever your desktop CAD is to the platform. You pump data in from Inventor, from NX, I don't care who it is. The data gets to the platform, it becomes a physical product, and it's utilizable. I'm not sure that's a word. Utilizable, is it? Okay, we'll do it. It's Fridays when I do those new word days, but today we'll do it. It's utilizable by other tools within the platform. Now, a bit more on that later. I think I have a slide I didn't unhide. But there's some other stuff here when it comes to Altium and Cadence and Allegro. 2D files. Those are actually still quite usable on the platform, but we'll talk about that in a little bit. Weird. Okay. So some of the key benefits. There's actually a lot of key benefits, and this is a hugely wordy slide, which is a complete PowerPoint faux pas, so I apologize for that. But I'm gonna break this down actually into, yeah, that's really weird. I'm getting kind of a different version of this running. I'm gonna break it down into a few of the specific things that I actually do want to cover. So we're gonna kind of cover 5 of the things that we have on this really big slide here. Interesting. Now, there's an extensive robot library. That is really one of the big game changers that we're gonna see on this one. And when it comes down to it, RBS, Robot Programmer on Cloud, the first step of RBS, or Robot Programmer, does all of these types of applications. So, kind of take a look at the list. Does anything fit on this list for everybody in here? Or you still need something above and beyond that? So we'll talk about each of these as we go. First, yeah, we'll talk about adhesives, I guess, first. If you guys give me 1 second here, I want to bop out of this and make sure I'm on the right version of this, because again, I had a couple of things kick out on me as we were getting started here, so let me just make sure that that looks the way that I want it to look. I'm a little bit thrown by that one. I had a 28 gig memory being in use by Adobe Acrobat on my computer, and I have no idea why, because there was no PDFs open. So that crashed my stuff as we were getting ready for this. So we'll just get started with this. So adhesives and contouring. First of all, when we're talking adhesives and contouring, there's a whole lot of different ways that we can do this, but it all has to do with the end of arm tooling. And again, the types of robots that you might have accessible to you, within your company already. Or if you're looking to do something, then setting yourself up for that by choosing from the extensive list that's already within the system. Now, it's really, really, really good for arc welding. When we're talking about arc welding, we're using the geometry on the parts. So that can be imported from CAD systems. Again, it's an extensive library that I'll talk about here in a second when it comes to the robot itself. But effectively, we have the ability to control everything. The approach angles, the start and the end of the weld. There's a lot of different things that we use the geometry for to drive it, which I'll show you in a little bit, but also that we kind of teach live and create these different tag points in space. And it kind of feeds inversely back into the robot to create this kind of stuff. Now, even synchronization of different types of assets. So obviously we have an arc welder, we have a bit of a gantry right here, and then a rotisserie. And all of these things are elegantly in sync with each other simply by the way that we just define the edges. Everything else kind of ties in and takes some angles of attack, and again, these rake angles and things, and it will automatically go ahead and create these tool paths from those arc trajectories. Now, machine tending is an interesting one. Machine tending, really there's a lot of uses for this. I don't care what your industrial application is, this is something that you can get some nice throughput if you're doing production level parts or high quantity of parts. So here we've got an ABB robot that's simply taking a blank off the table. It's going to take that blank and throw it into this Dusman, and then it's going to go ahead and pull out the finished part and then essentially rinse and repeat. Right? These are the things that people don't need to be standing there and doing necessarily in order to go ahead and do this rinse and repeat operation. Now, if you need to change the robot, it's kind of like an associativity thing in SolidWorks. We swap the robot out and effectively just hit run. All of the definitions, all of the things like our trajectories have already been defined. We're just swapping out the robot, which is effectively going to swap out what the code happens to be when we post-process here. But you have a ton of flexibility based on what's available to you, or again, the expense of a robot that you might be looking to procure. Now, tending is going even a different direction these days. 3D print farms are popping up everywhere. And I'm seeing people with hundreds of bamboo printers, and they're printing and they're kicking off parts, and they have a person walking around 24/7 pulling parts off, changing filament, putting things in, and putting new build trays in. So that's the kind of stuff that we want to automate again, get these farms working in a 24/7 type situation. Let's combine them all. So here we've got a couple of these universal robots up here, nice, and then we're going to go ahead and drop blank inside of our Omax water cutter from a few years back at the SolidWorks data set that we had. Now that same robot pulls it out, drops it over into another bin, where another robot pulls it from that bin, throws it over on this A-frame, and then we've got a FANUC robot out there that's going to go ahead and do a little arc welding operation while it then moves it off to the transport. This stuff is beautiful, and it's associative, so changes made to geometry trickle down to all of this stuff. So you really put CAD concepts that we create, not only the creation of the data, but also when change happens, how do we go ahead and assimilate that? A little bit of a different angle on that exact same data set, but I want to just see a little closer over here in this area, the action on the arc welder. It's really some great stuff. And you're not just, doing an operation, that's going super slow. You're not just doing an operation here where, we're defining that edge. We're also getting, obviously the details of the bead itself, penetration and temperature. Yeah, there's something up with this one here. Anything else you can think of? I'm going to warn you on this next one. If you have any type of, movement that's going to go ahead and throw you into a situation here, avert your eyes from this. I couldn't find a better version of this. But this is somebody who happened to have I thought it was a KUKA robot, but it's a Foundry robot, and they're going to use it to simply pour a beer. Why not, right? It's not because we should, it's because we can. That's a lot of what we do, especially at a reseller. Now, the fun part about this one is not only do they have a couple nice little jigs and fixtures here, but the method at which this beer is going to be poured is super elegant. So we've got a fixture that we go ahead and take our bottle. Again, the movement on this one drives you nuts if you look too close. Now look at all that. Isn't that a great operation? And then waste not, want not. once we're done with this one here, of course, this isn't a human that we have to make do this, so we can go ahead and swirl this thing around, make sure there's nothing left in that bottle, and we're good to go. So what you use a robot for, again, it's completely open-ended. That's not the point of this. The point is everything is there at your beck and call if you want to go ahead and utilize these in your business. Just another example of what we can do. Now, offline programming is super, super huge. It's not a common thing. Downtime is a real thing. Time is money. And anytime somebody has to spend the time sitting at the actual robot or at the pendant teaching it, you don't have productivity taking place. And that's why this stuff here is really kind of a game changer. The robots themselves, so this is where we really set you up for success. And I say we, but really Dassault Systems and the developers are the ones that are helping us here. You have so many robots available to you. There's 30 robot brands currently, huge spreadsheet that I'll show you here in just a second. And within that, there's over 2,000 robots and counting, completely curated by Dassault Systems. So you don't have to find some data set out there that's of an ABB or KUKA or some robot. It's all here and ready to rock. Not only, but all the translators are for this as well and the controllers. So there's nothing that you have to create. You simply get licensing and you have access to this completely curated library. Now, there's just a quick fix of it. Fanuc was actually a company that purchased SolidWorks in 1997 up in Rochester Hills, Michigan, and they were the reason I got hired way back in February of 97. So I always have a sweet spot in my heart for them, but they've also got one of the largest, sets of robots that are here. But of course, alphabetically, left and right, it's huge, down to Universal Robots and then all the way up to ABB and those. The point of that, though, is that everything that we're doing there has already been defined for you. Yeah, I'm gonna pop out of this again, guys. I did a bunch of work last night on getting some additional videos added to this, and it's my little crash there wasn't helping me. So if you will bear with me one moment, I just want to make sure that everything looks the way it should, because I've got a lot more richness to this than I'm been able to show you. I don't know what's going on with all that. Interesting. All right, well, we're just going to go with it. I added some additional videos last night that aren't showing up. So, no big deal. Okay. So, I want to show you a little bit about data into the system. Nothing's mystical about what I'm talking about. But SolidWorks data is where I always start. Everybody can start from wherever they do because of the extensive file types that are available. If you're just doing just a standard file open, file import, file save as, file export, whatever that happens to be, this is a pretty extensive list of files that we already do read. So if we didn't have SolidWorks connected to the platform, for example, and you wanted to import SolidWorks data, then you can go ahead and do that through just a simple file import. And similar to the export, when it's all said and done, the robot assemblies themselves, the entire work cells are all 3D XML data, which sounds like it's a neutral-ish file, but it's really kind of a neutral file on steroids as far as Dassault Systems is concerned. But things like basic step files, STL, and of course IGES and IFC, which when we get into these large facilities, industry foundation class can be important. That's typically a file from Revit. Now, this being SolidWorks data, once again, it's something that we create, we parameterize, of course, in SolidWorks, and then we put mates on it. And the mate thing, that's great. But the mates are made by a little processor called D-Cubed, and it's baked into SolidWorks. And it's not something that translates in any file type, essentially. It is a unique thing to SolidWorks. Here, we're just dragging and dropping directly from the SolidWorks interface into Robot Programmer. Now, the bodies come in. It comes in as a full component, so the assembly structure is there, of course, as you would assume. But it doesn't have the joints and the mates and those types of things. That is something that you can define. So in this case, you build end-of-arm tooling that's completely custom, and through a few simple operations, we're really just doing what we do in SolidWorks, grabbing a few key features here, adding revolute joints, adding hinge joints, adding the things that you need. Now, that's as far as the SolidWorks stuff goes, or any CAD data, frankly. You bring it in, it's neutral, it's a nice structure of hierarchy and a subassembly, but it still needs that mechanistic part of it added. But again, that's a flexibility that's really cool. When it comes to the robots, kind of the same operation, either file open, file import. I like to just drag and drop from Windows, but this gives you a little bit of a look at the list too. So Amran Nachi, Denzo's in there, Daheen Kamal. FANUC, of course, is a huge one, but it's all 3D XML data. Now, again, it looks like a neutral file, but upon drag and drop, it kind of reveals what really is baked into this. So when you insert any type of robot into a work cell, you're essentially just going to have the robot as structured with every bit of the mechanism fully defined. So when we're taking a look at this one here, I think I grabbed a Duznan, but on this particular one, we go into the joint commands and the jog, and you'll basically see that everything is defined when it comes to, of course, componentry, hierarchy on this one, but degrees of freedom, the accelerations, the ease in and the ease out values, everything about these robots is completely comprehensive. So it's really great to be able to not only customize those on a robot maybe you've created that isn't part of the library, but all this work is done for pretty much everything you either have, or of course, if you had this product and you were selecting hardware, you'd select something that's going to go ahead and work for you in that particular case. Now, all these joints and degrees of freedom, you find yourself as an engineer somewhat intuitive, right? You know what works and what doesn't, and that stuff's kind of cool. When you get into things, yeah, I'm missing a few things in this presentation, sorry guys. Defining these ports. We also do things that are reach studies and auto placement. And what that effectively does is allows you to say that I want to put a robot in a particular pedestal area, tell me where it can go. And it will actually do a nice little study where it adds different squares, shows you where it's a good one, where there's a collision, where it can reach and where it can't. And those aren't as intuitive as you might think, right? In the center of a table might think like you can get to where you need to when you have to reach a bin and then you have to reach where the part's going into the fixture. But sometimes those joints can kind of, handcuff you and you're actually too close to something. I can't grab my own elbow with my right hand. That's just something I can't do. So it's really great to have these automated tools to be able to control that for you. Now, when it comes to things like the tool center points and such, regardless of the origin of your data, this happens to be a torch tip, but the same tool that I did with that unique grabber that I just brought in from SolidWorks, it's really just about, for realism's sake, defining how this part's going to attach to the robot itself, which also has a base port, and then defining exactly where this robot is going to touch on a part. Now, for this one here, defining a base port is, again, just grabbing on geometry here. We can use a simple edge of a circular face or a circular feature, and then that's going to enable us to go ahead and put the base port right in the center of that. So now drag and drop of our tooltip onto our robot. The more important one, though, is the TCP. So you go down to the end of the wire that's extended out the end of this, also effective when it comes to the gripper, where you want that to index onto something. But just by going to the end of it and defining that as the tool center point, that makes sure that that is the point that's being referenced every time we go ahead and define geometry on the actual item being welded or items being welded. So really simplistic stuff. I tried to make it look complicated, but it's just a matter of defining a couple of things that are pretty key. Now, within the work cells are made up of things from a lot of different sources. I've got an auger here. This is a battery pack for a hybrid vehicle. Got a gantry with a robot on it. We've got a little rotisserie indexer here, and that happens to be a 2D file from pretty much anywhere, but a lot of times your floor plans are based on 2D, so why not bring it in and snap all of your tooling and equipment directly to it? That's really all that comes down to, is defining those types of things. Now, there's a bit more of a dance, and we have to define them specifically. So if it's going to be a thing like a tooling component, or if it's going to be manufacturing cell, or in this particular case, a manufacturing product, which is going to be a thing like the auger or the battery, we define what their role happens to be in these scenarios, and then from that point, that's where the automation will help kick in and take care of the rest of those. So again, we go ahead and define things like tool equipment. That's going to be your grippers, the end effector, that torch. So each thing gets those types of definitions. Now the DWG files, as I mentioned before, those can come from a lot of places like ePlan and Cadence and basic AutoCAD. But by bringing those in and just simply mating or snapping things together, you effectively create this cell from a bunch of disjointed things. This also could have been one single full assembly from CAD system of choice as well. So pick your poison as to how you acquire that data. As far as the tooltip goes, again, the end of the robot is going to have a base port defined on that. And if we just simply go ahead and select that face, there are indexing components in there that'll fit this thing perfectly and seat it into place. And then from that point on, everything is based on the tool center point as far as the robot's movements and positions. It really is just that easy. Now, arc trajectories are kind of the lifeblood of this, and there's a couple of different ways that we approach this. I did this one for our customer recently as just kind of a benchmark, but using just a basic table, a virtual pedestal over there on the left-hand side, we're really just selecting, for the most part, right on the geometry itself. Now, that's a good way to start things, but it's not always the entire story. So what I like to do on a project like this is I'll go ahead and start to define contours. Now, the contours themselves could literally be edges of the part, but in a lot of cases, there's gapping built in, chamfers built in, and you end up with kind of virtual edges that you need. So when you pick an edge to define it, you also define it based on other faces, and then that allows us for hitting, a virtual intersection versus a literal edge. From there, we've got our start points and our end points. And when we're defining things, if you're comfortable over here, you can define the start offset, the end offset, and the overall length. One of those three always has to be driven, though. So you have to choose whether you want to have offsets drive the length or one length and one offset drive the other offset. But there's on-screen handles, and if you're just a little bit explorative, you can see that there's arrows out there. That should be enough to kind of drive you out there to go ahead and start clicking on things as well. So if you need to change the direction of an offset, for example, we go ahead and select it, and it simply changes the end to the start and the start to the end and vice versa. Things that are nice to do after you've run a quick test, and there's collisions involved, and maybe we have to approach it from a different spot or a different angle. Now, in some cases, you can go ahead and drag those off the edge. I have these as driven ends, and I can only drag the one end since the other happens to be driven. But again, those all stack up into the overall picture of what this edge is going to have to be. From there, it's a little rinse and repeat. But when you start to get additional edges in, of course, you've got to go from the first one to the second one. And what that effectively does is now starts your transition, the pullback, the transition over the top, and then again, approaching inside that edge. And for here, it's just rinse and repeat. Once again, we'll hit this third edge. So I'm going to kind of fast forward on that one a little bit. Now, with all those contours in place, I'll let this one speed up a little bit. We start to get the orientation of the tool itself. And again, on-screen handles, all these green arrows are really the most enjoyable way to effectively interact with this. So we can change the angle of the head, and we're not seeing the entire robot out there, but everything that's happening with the robot is being adjusted as we tweak these angles. So we're doing this in order to clear those edges so that we don't have a collision as these things go. And those are the kind of fine tunings that you can do just on screen by teaching. Now, teaching also can include pulling that robot out to a specific spot in any way that you want, and then defining that as a point. And what that's going to do is put that into the overall tool path as it processes. And sometimes those are pull away and move points instead of the approach points or clearance points. So we just go ahead and set this up a little bit, and again, just ready to rock. Now, all that said, I'm going to drop another edge out on the front here, and we'll just fast forward through this a little bit. But by putting another edge out onto the front and then flipping the approach, because I just want you to see something, you can see that as we actually run these simulations, it does lay down physical beads. It's fun to watch it move, but I think it's even more fun to watch it physically lay down the fact that there's a bead being placed there. So here we're going to go ahead and run this simulation to actually run over the other end. There we go. I'm going to speed this up when it gets out of screen here just a little bit. We used to have people say when we did machining, they wanted to see chips fly. I'm like, wow, that's a lot of extra effort just for a visual, but it really does have a lot of impact. Now, the next one's that edge that's the other direction. Doesn't quite like the direction that it goes and has to flip to hit it. But you see how the entire robot does what it needs to do to reach the points as defined. And that's really why I find this enjoyable, is you can go after it, you can see what it looks like and either make it efficient on your own, or there's some tools that actually allow you to go ahead and build some efficiencies into it automatically. Get out of that simulation. Now, you just export. It's like any other G-code. You're going to choose whatever controller this happens to go towards, and then you just hit export. But the controllers are there. You don't have to write these or customize the post-processing for any of this. In this case, we're going to go ahead and just throw the actual task over, and from there, a couple of next, and go, and that's it. Really kind of using is believing, though. So that's one of those things where, we can get a hold of you, get in a meeting, maybe evaluate what type of equipment you want to use for this, and do a benchmark for you if that happens to be something that really gets you over the top on whether this is useful for your operation or not. Now, the real building of this is that it's kind of the start of what you've been hearing from all these other keynotes that we're doing, is the virtual twin, right? The real digital thread. I've heard that term for a long, long time, and it sounded like a great idea. We're finally actually getting to the point where we can handle it based on capacity, based on scanning technology, the manufacturing process, and the full the circle of that when it comes to what goes out the door, being validated back to what the design was. And that's the thread that we're talking about. Now, continuity, yeah. Collaboration, that's really what we do anyway. But the point is the associativity, first of all. I'm a SOLIDWORKS guy, and if I make a change that has to be made in more than one place, I have to assume everything has been either overridden or is manual. I'm a guy who wants to make a change in one spot and have those dimensions affect everything that has to happen. So the associativity to me is the lifeblood of what we do. Other than that, it's might as well be just manual and 2D. But by changing anything in the SOLIDWORKS designs, the grate that you saw there, the size of the actual table that it was on, even just repositioning the robot, all that stuff has effect. But if the grate gets thicker and those edges get longer, now we've got some things that are associative to the geometry we use to define it. But it gives you that one single source of the truth. And I hear that statement all the time. I don't know if anybody has a single source of the truth just based on how we do file save as and pack and goes and copies and emails and all of that stuff. That's where the platform is really trying to kind of consolidate all of that. If the data is on the platform and can be shared to anybody from the platform and then is used in other items on the platform, then we're not disassociating some sort of data set in order to either squirrel it away locally or send it to somebody else so that we can get feedback and then try and inject whatever they said back into the actual data set. We've got a lot more going on with the collaboration tools and the share and markup and some of the other things actually that we're going to hear this week during the platform that I'll let them talk about on the main stage. But easy collaboration between designers and robot programmers. You can be the guy with the same hat on, and of course it's super easy collaboration. But being able to make a quick change and just tell them to rerun it, it couldn't be easier. You don't want to have to redo anything from scratch just because change, which is constant, had to happen. And then robot engineers, if they're in step with everything else that we're doing and frankly productive because they're never having downtime, that's a big deal. Like I mentioned, we're doing this all virtually. Now, we can take one of these work cells. This is kind of some future-ish stuff as far as what my presentation is, but this is what's in the Delmia higher-end tools and the virtual commissioning. We've got a scan. And that scan can actually be utilized in an interference detection with real analytic data. So we're getting bigger when it comes into factory placement, especially when it comes to floor space, dealing with pipes and other interferences like support poles and stuff, and then still being able to run it visually within that space to give you that full collaborative feel of what we're seeing. And this one here is super elegant because obviously the rotisserie and the robot are working in stream with each other really nice. Now, that's just the tip of the iceberg. I say that because icebergs are cool. Oof, sorry, we're late in this one, so if you got that pun there, then that's good, but it's after lunch, so everybody's kind of sleepy. The point is where can you go from here? Well, when we're talking the platform, this map comes up in my head a lot, because this is how I visualize the platform. Tons of things, manufacturing bill of materials, engineering bill of materials, machining, things that aren't part of my job. But somehow, projects come in the front of the building, and product goes out the back of the building, whether I'm doing all of it or I'm only doing one step. And the thing is that everything drives everything when you're talking about, especially a larger company. When you're talking design drives your engineering bill of materials. But design isn't just CAD, because a lot of companies are doing electrical and PCB all by themselves. But all of that's driving the engineering bill of materials based on what's on your SOLIDWORKS screen. Now, of course, that's got to go ahead and drive the manufacturing bill of materials. What's in the box? What actually gets shipped to a customer? The final products and service parts, right? Extras. Now, from there, documentation gets created, right? And that documentation drives the manufacturing planning. And finally, we get over into the robot part of this, because once those are documented, now we can go ahead and start cutting chips. Realize what this starts to look like after a while, right? But that's how a company works. You don't know everything, and just somehow magically everybody does their job and it goes out there. The point of this is that these do have to happen in every company, and there are people that do each of these processes. Whether you're aware of somebody in projects or doing QMS, which we're hearing more about, and that kind of stuff. But the platform takes it all and gives you the opportunity to connect each of those pieces. They are in organized verticals, and they do have processes that step from one to the next. Now, for what we're doing right now, I'm only talking about this part of it. Again, just dipping my toe in the water. But if we want to do more than robot programming, then we kind of get into things like process management and machining and milling and manufacturing planning and actually the virtual factory. So we get deeper and deeper into that stuff. So whenever we're talking about the full virtual factory portfolio, robot programmer, on cloud, first little piece of that. But when you get into more digital twins and the next step up, now you've got other things that you can do. So again, spot welding, additive and subtractive manufacturing. So that's going to be CAM with the end of the robot, right? Different than what robot programmer can do, but that's pretty cool stuff when you've got an end mill on the end of your FANUC robot and you're doing, whatever, 5.5 axis stuff. Then the virtual commissioning. Now, virtual commissioning kind of takes what I showed you before with that scan data and with the nice robot cell working within that. And while you're sitting at the virtual teach pendant, not at the real robot taking up its time, you're actually just sitting at what looks like you're at the robot, doing all the work and validating it right here before you ever push the code to the robot itself. So whenever we are talking about concurrency, well, not having to take a robot offline in order to get it ready for the next job is a huge way to stay concurrent. And it's not rocket science. It's just something that you have to decide to do and maybe look into, and we can kind of take you in that direction. So like I mentioned, I am not the end-all be-all when it comes to this at Go Engineer. In fact, I am the beginning all be-all when it comes to these kind of things. But if we need bigger, more heady conversations, we got guys like Don Glasky with us that are doing absolutely all of these applications right up through kind of a Mike Buckley level guy here at Dassault. So if you've ever met him. But where we live, this is the center of it all. I don't care how it gets here, but when it comes in, it can be used by these other areas really, really seamlessly. And I've gotten more and more in love with the platform just based on how it's bailed me out more and more the last year and a half or so. And it's gotten to a point where I think it's just ready for prime time, especially the things that are game changers. The robot programming, X-Shape, I find is a game changer because it's something SolidWorks simply can't do. And the performance and the stability and connectivity, Dassault has really gotten their stuff together on all of that stuff. So the stuff that's available, again, it's vast and you don't know what you don't know, so just keep asking the questions. Speaking of questions, are you still awake? And I see eyes here, so I'm good. But right after lunch, I was like, oh, this is really scary because food coma is a real thing. So I'll try and answer some questions if you have any. If not, I'm glad you spent a rapid 40 minutes with me here, and we got about 5 more before this is done. Yeah.
Yeah, I mean, this is a lot. I mean, it's awesome. Kind of like just wondering, is there like, resources, for somebody that actually want to learn some of these, to be able to utilize.
Mm-hmm.
Is that resources built into 3D experience that kind of like, showcase some of the stuff that you've done, that you showcase?
Yeah.
Is it built into the 3D experience?
Yes. So the question are the resources, the learning resources available? Because, having a person like me sitting next to you, not always a resource you have. A lot of what we were taught, so I'm from Michigan. I went down to Royal Oak, Michigan, down in the Detroit area to go on site to the Dassault headquarters to learn this stuff. However, the tools that we used were actually the online 3D learning, 3D experience learning stuff. So everything with Robot Programmer is an online-based course, fully comprehensive, walks you through. Go back and do the things that you needed to do more than once, and that's kind of how I get myself smart with it. But you can be completely self-sufficient because those learning resources are all built into the 3D experience educational space. So 3DX EDU, I think, or 3D EDU. There's a space for it, but the 3D experience learning space has got it all. Yeah, blinding. Yeah.
I had a robot that was doing some welding on what was a diaphragm steel, so it was a piece of stainless steel, and then we had these plates that sit on the top,
Yeah.
and then we then measure the pressure between the two. But obviously different plates for different materials and stuff like that. And can the robot, the virtual robot, because one of the problems we had was it would overweld and then it would damage it, or it wouldn't weld and it would break the seal. So we went through loads and loads and loads of plates, working out for every different material how to get it so it was right. We did that manually with the machine.
Yeah.
We probably spent then rather than going through all this different blades and materials.
Yeah.
Can the virtual stuff work out any of those things?
So I don't use it, but I have been told, so I'm going to leave it there. But simulation kind of overlaps. That's where these things kind of get there. And simulation is a really, open-ended term. Whether we're talking structural, basic linear stuff, those are things people understand. But simulation of weld beads, penetration, temperature, depth is something that there's a different application that either it is part of the bundle or is just a little separate offshoot for what you need to do for those. But it's all, of course, based on the type of robot, the type of, the setup, right? Type of material, thickness of the plates, of course, that kind of thing. But yeah, they've got some stuff in there that's more or less that. In fact, some of the simulation I saw even last year, I believe, here at World, was the tearing of a paper strip, right? Those little zipper strips that are on the back of an envelope. The simulation was showing the nonlinear of those tearing and the fibrousness of it. So the propeller heads at Dassault Systems over there in France, they've got some really fantastic stuff. Price tag is usually the prohibitor because that is high in code with small user base usually, and that makes it expensive. But if you can find somebody who's got it or whatever, then you can help their costs by utilizing them too. But so long answer is, short answer is yes, but the long answer is, look into it a little bit deeper to see if it fits your needs and if you can afford it. Right on. Anybody else? All right, I'm gonna see if the food truck lines are still out there. I know they're not, but the lines might still be. All right. Well, I wanna thank everybody for just hanging out with me after lunch here inside and, a few minutes to hear me gab. So sorry about the technical issues there. I appreciate it. If you want to come up and see me afterwards, I've got cards too I can give you if you want to get a hold of me. But I very, very, very much appreciate your time. Time is valuable, and it's just one of those things that I don't understate. So hope I didn't waste it, and have a great time here with the rest of 3D Experience World. All right. Thanks a lot, guys. Take care.